Okay, so uh, hello and welcome everyone to this video series on recursion. So in this set of videos, we'll learn the recursion from very basics and we'll solve easy to medium level problems on recursion. So with this, let's get started. So yeah, recursion is function calling itself directly or indirectly in very simple words. So down here I have given two examples for recursion, among which one is the direct recursion and another one is the indirect recursion. So let us understand both of this example in respect to the definition. So first one is the example of direct recursion. So here, as you can see, the main function is calling some function f, and this function f is calling itself again here. So since function is calling itself again and again, so it's an example of recursion, and it's direct. It is the example of direct recursion because the same function is calling itself from inside the function's body. So hence it's the example of direct recursion. Similarly, the recursion can also be indirect. So the second one is the example of indirect recursion. So here the main method is calling the function f, and that function f inside its body is calling some another function g, and this function g inside its body is calling some another function f. So so this is the example of indirect recursion. So again, coming back to the definition, recursion is nothing but function calling itself either directly or indirectly. So here the function is calling itself directly, and hence it's the direct recursion, and here the function calls itself indirectly. So here function f calls the function g, and g in turn calls the function f. So function f is calling itself indirectly, hence it's the example of indirect recursion. And yeah, either it may be direct or indirect. It's both of these examples are the example of the recursion. So yeah, so let us move ahead. So I have given here the typical structure for any recursive function. So any recursive function will have this kind of template. So it will have this obviously it will have the return type, then function name, and then parameters that it takes. Apart from that, there are two important things that any recursive function will have. One is the base case, and second is the recursive call itself. So base case determines when this recursion will halt, or it will say the halting condition for the recursive calls. And the recursive calls are, as we saw, they call this function itself directly or indirectly. So coming back to the example here of the direct recursion, to understand this structure better, so here if you can see, this is the recursive call. Here the recursive call is this one, and this one is the base case, the condition which halts the recursion. So since this so this is the recursive call, since this function is calling itself here, and this is the base case because you can see the parameter is getting changed here. Actually its value is getting reduced, and this base case is ensuring that when the value falls below 0, it will return. So this function will return, and hence the recursion will halt. So yeah, so I hope you understood this base case and recursive call with this example. And so as you can see, the parameters that are passed to the function having recursive call should the values of those parameters should change. Otherwise we might go into infinite recursive calls. So that is something should be avoided. So proper writing of the base case is important, along with the proper modification to the parameters that are passed. Let us now understand to how to draw the recursion tree. So for drawing the recursion tree, I have taken two examples here. So let us start with this first example. So drawing recursion tree will help us in solving the recursion problems, and hence this is very necessary thing. So let us understand how to draw the recursion tree. So yeah, let us start with this first example. So here we have this main function. This main function is calling f of 4, function f with the argument integer argument of 4. So yeah, with and what this function f is doing, this f is again a recursive function, and it is its return type is void, and it's taking integer n as its argument, and this is the base case here, n equals to 0. If n value of n becomes 0, then we'll return, and else we'll recursively call this function f with the value of n minus 1. So yeah, so and before calling we print the value of n, and after the call we again print the value of n. So let us look into how we can draw the recursion tree for this. So for this I've already drawn the recursion tree. So as you can see here, for this example, for f equal to 4, what is being done here is that when f of 4 is being called, what it does is it prints the value of n, which is 4. It calls f equals to 3, f of 3, and then again after calling f of 3, it prints the value of 4. And same goes for the f of 3. So f of 3 will print the value of n, which is 3. It will call f of 2, and will, after this f of 2 is finished, it will print the value of n, which is 3. And this will go on until we hit the base case, which is n equals to 0. If you remember here, when n is 0, we'll just simply return. So when n equals to 0 is reached here, we'll simply so base case is reached here, and we'll simply return the function. So what will happen is f of 4 will print 4, it will call f of 3, and it will wait for f of 3 to finish before it prints the 4 again. So, and similar things will happen for f of 3. So the order in which it will be the output will be printed will be from top to bottom and from left to right in the recursion tree. So this entire thing is recursion tree, and the order, I mean the output, the way the output will be printed will be from left to right and from top to bottom in the recursion tree. So the output will be like this: 4 will be printed, then 3 will be printed, then 2 will be printed, then 1 will be printed, and then again 1 will be printed, since f of 0 will return. Again 1 will be printed, then 2 will be printed, then 3 will be printed, and then again 4 will be printed. So yeah, so this is the recursion tree, and the output that will result out of this program will be 4 3 2 1 and 1 2 3 4, which is this 4 3 2 1 and 1 2 3 and 4. So top to bottom, left to right. Yeah, so I hope you understand this, how we draw this recursion tree and how we trace the output using this recursion tree. Again, let us take another example to understand this recursion tree better, how to draw the recursion tree better. So this is the another example. Here again the name of the function is f. It returns void, so its return type is void, and it takes integer n as the argument. From the main we are calling f of 3, and for this function f, we have this base case similar to the previous example, that is when n equals to 0 is reached, we return. And here we have two recursive calls. So f of n minus 1 is called, then we print the value of n, then again f of n minus 1 is being called. So let us understand how to draw the recursion tree for this case. So yeah, so I have already again drawn the recursion tree for this example, and it looks something like this. So yeah, so it looks something like this, and let us understand this again. So here from the main f of 3 was being called, and then when once f of 3 is called, then recursive calls are being made. So let us understand. So f of 3 is being called, and what it does is it calls f of n minus 1, which is f of 2, prints the value of n, and again calls f of n minus 1, which is 2. So f of n minus 1, then printing, then printing the value of n, and then f of n minus 1 again. So here f of 2 printing the value of n, which is 3, f of 2. Similarly, f of 2 will do the same thing. It will call f of n minus 1, which is 1. It will print value of n, which is 2, and it will again call f of n minus 1. And similar thing here for f of 2. And f of 1 will do the similar thing. It will print it will call f of 0, it will print 1, it will call f of 0. And this will go on for all other f of 1s here, here, and here. And later, once we reach this f of 0 case, it's the base case, right? F of 0, where n is 0, is the base case. So we'll simply return, and yeah, so all these calls will return here, 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 everywhere. And this is what is the recursion tree for this example. So okay, so now since we have already drawn the recursion tree, let us trace the output that we'll get out of this program. We can trace the output using this recursion tree. So again, as I said earlier, to trace the output, what we'll do is we'll go from top to bottom and left to right. So here the output will be, we'll go from top to bottom, left to right, 1, then 2, then again 1, then 3, then 1, 2, 1. So 1, 2, 1, 3, 1, 2, 1 will be the output. Yeah, so 1, 2, 1, 3, 1, 2, 1 will be the output of this program. As an exercise, you can take this program and run using G++ or GCC compiler, and you can check the output. So this is what will be the output. Okay, so I hope that you understood what is the recursion, what is direct recursion, what is indirect recursion, what is the structure of any recursive function, what is base case, what is recursive call, and how to draw the recursion tree. So in the next video, we'll look into how to solve a very simple recursive problem or very simple recursion problem using a couple of examples. So with this, we'll end here.